Hi guys, I'm Bonclad H. Vitone, and I'm back again for another video tutorial. In this video, we have given two problems to solve in mesh analysis and nodal method. So let's jump to the first problem. So this is the first problem. So for solving this first problem, we're going to use the nodal method. So first, let's applying the KCL at the node VO. Node VO. So I1 is entering VO, so it's positive. Then I2 is leaving the VO, so negative, and IL is leaving to the VO, it's negative. Then equal to 0. Then we're going to use the Ohm's law here. So EA minus the VO, then divided by the R1. Next, minus to the VO minus EB, then divided by the R2, and minus VO minus 0, then divided by the R3. So substitute the value, input the value of EA equals 12, R1 0.8, the EB is 12, then the R2 is 2, then the R3 is 8. So ibuwag na to ang para madali sabot. So we have here 12 divided by 0.8 minus VO divided by 0.8 minus VO divided by 2 plus 12 divided by 2 minus VO divided by 8 equals to 0. So bali na to ang mga negative sign because so we have here 12 divided by 0.8 plus 12 divided by 2 equals to VO divided by 0.8 plus VO divided by 2 plus V8 VO divided by 8. And after that, using the calculator, the answer is 21 here. And answer for this is 1.875. So divided by both sides, so we cancel. So the answer for VO is equal to 11.2 volt. So for getting the value of I1 and I2 and IL, we need to substitute the value of VO. So here, EA minus VO divided by the resistance of R1 equals 0.8. 12 minus 11.2 divided by 0.8. So I1 is equal to 1 ampere. We're getting I2. So we have here VO minus EB divided by 2. 2 is a resistor, the R2. So 11.2 minus 12 divided by 2. So the answer for I2 is equal to negative 0.4 ampere. The next, the IL, so VO minus 0 divided by 8, which is the R R3. So 11.2 minus 0 divided by 8. So the answer the answer for IL is equal to 1.4 ampere. So this is the solution for problem number 1. So next problem. So this is the problem number 2. So for solving the problem number 2, we are gonna use uh, the mesh analysis. So first, uh, let's apply uh, the KVL at the mesh A. So this is our mesh A. So we have here EA minus RAIL minus R2 times IA minus I1. So substitute the value. So we have EA is 24 minus the RA, which is 1, uh, then minus the R2 which is 12, then times IA minus I1. So transpose this to the other side. So we have 12 I1 minus 13 IA equals to uh, negative 24. So this is our equation number 1. Then for the mesh B, going to use also KVL. So in mesh B, we have R2 times IA minus I1, then minus R1 I1 minus R3 times I1 minus IB equals to 0. So put the value. So we have R2 is equal to 12 times IA minus I1, then minus the R1, which is 4 I1 minus R3 times I1 minus IB equals to 0. Then times here, times, so we have 12IA equals minus 12I1, then minus 4I1 times here, times, so 8, so negative 8 I1 plus negative times negative, so positive 8 IB equals to 0. So negative negative 12 I1 minus negative 4 I1 and minus 8 I1, so equals to negative 24 I1. So we have here 12 IA minus negative uh, oh, negative 24 I1 plus 8 IB equals to 0. So this is our second equation. So for the mesh C, so this is our mesh C. So we have here R2 times I1 minus IB, then minus RB IB minus EB equals to 0. So put the value to R2. So R2 is equals to 8, then times the I1 minus IB and minus 2IB, then minus 28 equals to 0. So 8 times I1 equals 8I1, 8 8 times negative IB, negative 8IB, then down here. So 8 negative 8IB minus negative 2IB, so equals to negative 10IB. Then transpose here, balhin mo spikas, and 8I1 minus 10IB equals to 28. So this is our third equation. So to get the value of the IA, I1 and IB, need to use the calculator. So wait, up here, calculator. Wait, calculator. So the first equation, uh, we have negative 13 IA, then the I1 is 12, then the IB is 0, and negative 24 equals to negative 24. Next to the equation number 2, the IA is equal to 12, and the I1 is negative 24, and IB is 8. So equals to 0. So IA, walang IA, so 0. So I1 8, then IB is negative 10 equals to 28. So answer for IA is equal to negative is equal to 1.8 ampere. Then for I1 is negative 0.0377 ampere. Then for IB is negative 2.83 ampere. So for solving the node VA. Okay, so VA, we're going to use apply the KCL at the node VA. So yeah, where IA is entering the node VA, so it's positive. Then the I1 is entering, so it's positive I1, and the I2 is leaving the node VA, so that's why it's negative I2 equal to 0. So, so so input the value of IA. So IA is 1.881 plus 0.0377 minus I2. So transpose the I2. So we have uh, so the I2 is equal to 1.85 ampere. So next, the node VB. We'll also use the KCL get the node VB. So we have the IB is entering, so that's why it's positive. Then the I1 is leaving, so negative. The I3 is leaving, so negative, so equal to 0. And input the value of IB and I1. So we have, so the IB is 2.83 plus 0.0377 and minus I3 equal to 0, so transpose is I3. So I3 is equal to 2.79 ampere. So this is the final answer for the problem 2. So that's all. Thank you.